Hello all, welcome to my channel. As promised in my last video, we will be going through the solutions for the scenarios where we say Spark job is slow, running slow. So in the last video, we had seen multiple places why a job can be slowed down. For example, input layout, the stage, uneven partition, even partition with too many large number of partitions or too many small number of partitions, big DAG. So all those scenarios we have seen in the last block. So as I mentioned, there is a follow-up. This is a follow-up to the previous blog. So in this blog, if you see, these were the scenarios where we are seeing that the jobs can get slowed down. So uh, in this video, we will see the solutions that are there to fix this issue. So first is input, or source layout. So we can, if we can partition data in based on the query pattern that we have, we will see jobs running or consuming only or reading only the files that are needed. Also, we can decide how many parallel threads will be used for the partition discovery, and what should be the threshold. So that also can help us in identifying which partition should be read. Also, we can have the layout in such a way that it reads certain amounts of data before creating a new partition. So like for example, if we have two files of let's say 8 GB each, so instead of reading them as a one partition, we can set the partition max bytes numbers to let's say 128 or 256 GB. So if we set 256 and if let's say 8 GB file is there, so it will automatically create around 32 files so that it can be read in parallel. So that helps us in maintaining a right input layer. So input parallelism with right size of each partitions. Then we can do bucketing. So bucketing is something which helps in cases we are not using any table format, but we are using Hive style layout. So bucketing does help us in reducing the number of files that gets read for a particular job. So bucketing is another which will help us in sort merge join as well. So bucketing is very important if we want if we know that our jobs are slow because of the reading process itself. We can before reading the next time we can repartition the tables with buckets enabled, and that will help. Then if we have lot of too many small files, we can merge them into a bigger file. For example, instead of using 60 MB, 360 MB files, why not create one file of 180 MB, which, or let's say we can create of 256 MB as well. So that makes the parallelism also process the right amount of data. Let's example, and in the last case, we have seen cases where the slowness was coming because of the non-splittable files, for example, JSON. And so if we have hybrid data file format like row grouped or column partition like ORC Parquet, hybrid data files formats have a good read and write performance for the same thing. So if we have the possibility, we can switch to an splittable file system to work on that. So we can just before writing the data in JSON itself, we can do this rewriting into a format which is more suitable for distributed processing. A multi-line, as we had seen in the last blog itself, we can instead of doing the auto multi-line setting to true, that reads everything in one particular process, which causes the job slowness. If possible, we should refrain from doing multi-line equal to true, and we should avoid using too much of complex and deep nested data. If we have such kind of data that is coming from the upstream, we should have a separate process which flattens the JSON out. So JSON auto flattening we can do, and then we read the files. That will help us in speeding up the process. Also, we should avoid infer schema. Infer schema is something which has to uh, first read the entire data set and then decide which data column should have which the data type. So that becomes a two-step process of identifying the schema. If we provide the schema beforehand, that step doesn't happen. So this will help us in reducing the time. Then register as table. So Spark data frames we can register as a table in the metastore, and we store the file location and schema information. This enables Spark to leverage metadata for optimization. So instead of directly reading the file, uh, we should be treating the files as a table. So we first have to register that in the meta catalog itself. Uh, we can also utilize file formats like Iceberg, Delta, which have advantages of the optimization that comes with them. For example, manifest list, and row skipping based on the row group and stuff. So there are certain things which are there, which are optimization on top of the raw file system. So file format like Delta or Iceberg can help. Slow stage, for example, let's say if we have uneven partitions, that means a skew, so we can do a salting. So salting is a process of adding random keys so that the distribution becomes more even. And how we do is that we add a column. We add a column which is let's say salted ID. So what we do is we concat that ID with a literal value of a random function that is there. So let's say this random function, what it does, it takes the uh, how many shuffle partitions are there are defined. So let's say if it is 200, so it will generate 200 random values and each one will get a dash. So that way we will ensure that the partitions that will get out of this table, let's say if you join based on this, because this decides the number of keys that number of partitions that gets after a group by or an joins in that case, because these partitions are there, and we have distributed the keys based on the number of the partitions, so each one of them will get data in an even fashion. So that helps, and that's how salting reduces the chance that is happening due to slowness it is happening due to uneven partition or a data skew. We could also do repartition or coalesce. So repartition is to increase or decrease both. Coalesce will only decrease, but repartition will have extra shuffle stage added. So choose wisely if we have to do repartition or we have to reduce by doing a coalesce. AQE has certain optimization that we can do. For example, if the job is running slow due to an skew join, so we have skew join enable, coalesce partitions, advisory partition size. So there are certain configurations that we can use to leverage AQE. In cases we have even partition, but though there are too many partitions, so we can do a coalesce to reduce the number of partitions which are there. And then we can decide on if we have too few partitions. Let's say if we are having very large partitions, so we can do split, or we can do a repartition based on a column which decides the size, or we can increase the number of partition by reducing the value setting of max partition in bytes while reading, so that will create more partitions. And then high task concurrency, this is due to this will cause GC overheads if we have too many tasks running in parallel. So we should ideally keep the number of cores that should be there is between 3 to 5. Uh, this is not a hard number. This is something which is coming from Hadoop systems, but we should try an experiment to find out the sweet spot of how many executors would be there to reduce the GC overhead. So this is there. One thing I have noted is dynamic allocation does save the resources. Allocation saves the resources in the shared environment, but it does slow down jobs. So certain times it will be better if we can just disable dynamic allocation to see if our jobs runs faster without dynamic allocation, because it will require a lot of overhead of allocating and deallocating the resources. So either we have to set this value correctly, like not this one, execute idle timeout to make to arrive a sweet spot that balances cost as well as the parallelism. Uh, Complex transformation can cause slow jobs, so we should avoid doing complex transformation. So if we have to do, we should not rely on some extra uh, now functions, or if we can do things in PySpark or native PySpark code, we should do that. If we have to rely on certain extra packages, for example, in case of Python, so we should use UDFs which are arrow enabled, so that will do save or do in speed up the process. Predicate not being pushed out, that as I have mentioned, push down, we have to enable predicate push down in Spark as well as Hive. Also ensure that your queries or partition predicates are used in where clause. So if you have partitioning scheme based on, let's say, X column, and if you are not using that in the where clause or the join condition, that way it will not be pushed. So we have to do that. And UDFs, don't we can avoid UDFs and UDAFs. We can rely on UDTF table functions, and also when we are using, we should be using the ones which are arrow enabled. Slow executor is something that can be caused because of GC and whatever. So we can change certain Java options which are there, which can switch to GC algorithm which is more suitable. For example, G1 GC or parallel GC or the new one even one ZGC. And we can use compressed ops. This reduces the memory size. If this is important if we have the memory size is less than 32 GB. Otherwise, it is, I think it's all already taken care by systems which executors which have more than 32 gigs of memory. Serializers also is something that we can think of, which is cryo serializer, or in the newer ones, which is Fori, and for other ones we can use this arrow enabled as well. Uh, DAG, as I mentioned in the last video as well, we can break the DAG lineage by adding a checkpoint. So this is something which is good, but this should not be your normal go-to solution. It should be something that after do, uh, doing a due consideration that whether the job is slow because of certain reason, then only it will do. Uh, in case of a multi-tenant cluster where you have scheduling delays, we can use schedulers like Volcano or Unicorn, which has queuing capacity. And resource contention is, if it is there, then we can choose to have fair scheduling, or we can use sorry, we can use the fair scheduling mode, or we can use yarn queues as well. So those are things are that something which we should be doing. And also, if in our code, if we can reduce the work that we are doing, like if we have work deduplication, like if the same work is being done twice, we can combine it into one and then do. For example, here we are doing join and then doing a filter. But and then doing some transformation. So in the we will notice that the join happened twice. And then to speed up this process, we can call a cache in between to process the join data frame so that it join only happens once. And the optimizer will use a shortcut to fetch the data instead of computing it from the source. So these are certain kinds of things that we can do. And again, as this is part of that, I have been talking about the series where we have five sources, 5S as a source of Spark challenges, shuffle, skew, spill, storage, and serialization. So these things, if we keep in mind, we can debug any slow application and try to fix how uh, to run it in the expected SLA. So this was it for this video. I will catch up in another video. Till then, have a nice day. And if you like this video, do share and spread the word. Thank you.